especially part B on number 2. That was, I think, the hardest part. Okay, so we're going to go through, we're going to practice finding our component form, finding our magnitude, and finding our angle. So our component form, ooh, wrong pen. When we're looking for our component form, that's when we are doing our kind of angled brackets and we're doing the change in our x's and the change in our y's. That's what we mean by component form. So I tend to build it right in the bracket. So if you pull up, like when I post answer keys and stuff, I'm just going to work it right in here. So I'm going to take my B point and take my x value, so that -5, and we're going to subtract the x value from my A point, 3. So this is going to become my x term in my vector. We do the same kind of vibe with my b, or with my y's. So we're going to take our -3 from the B point and subtract the -1. And I usually just write it just like this. So then we're just going to simplify each of those. -5 minus 3. -8. -3 minus -1. -2. That is the component form of this vector. What quadrant is this in? 4. If it's negative? 3. Yeah. So we know if we were to sketch this out, it would be somewhere down here. Because my x and my y are both negative. That means we're in quadrant 3. That's how we know that. To get our magnitude, that's when we're going to use our distance formula and thing. So the magnitude of AB, we're going to do the square root, and we take our, I guess I don't need it that long, not until next bit. We're going to take our -8, our x, and square it, and add it to the -2 squared. So we take the x from our vector and square it, and the y from my vector, and we square it. I'm going to take the square root of both. So that's going to give us the square root of 64 plus 4, also known as the square root of 68. What does that simplify down to? 2 square root of 17. And that's our magnitude. We don't necessarily need to have it as a decimal. We can leave it in radical form. That's fine. You can put it as a decimal if you want to. If we're talking, when we get into like the story problems and we're talking the actual distance, then we want a decimal. But when we're just talking points here, radical form's fine. But when we're starting to talk about things like airplanes and ships and things like that, 2 square root of 17 isn't particularly helpful. And our last piece of this is to find our angle. We're trying to figure out this angle here. It's coming from standard position, so it's coming from my x-axis on the right-hand side. So our theta is going to be the inverse tangent. So arctangent. And we do our y over x. So my y is -2. And my x is -8. So we're going to do arctangent or inverse tangent of 1/4. What do we get when we have inverse tangent of 1/4? Yeah, 14.036, blah, 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 blah. I'm going to do 3 decimal places because it's what I wrote down. 14.036 degrees. Is that in quadrant 3? That's in quadrant 1. That's way up here. What do we need to do to make this be our quadrant 3 angle? We're in degrees.
180.
Add 180. Because it gives us, in that domain of our inverses, it was from -1 to 1. So it's only given us half of our circle. So to get the other half, we're going to have to add 180. So we're going to add 180 to get to Q3. So our angle is actually what? 0.036. That's a point. Looks like a comma from here. Questions on any of these pieces? Because I know we just did this one time yesterday, and that was not much. Once we get the hang of it, the calculations are not super complicated. Like most of it's typed in the calculator. Or at least they're not super complicated yet. So we're going to get really comfortable with these because eventually our vectors are going to start to look kind of gross. But we'll still be doing the same calculations. So let's do another one. We'll probably just do one more today. Different numbers? Okay, good. They are different numbers. They just look really similar. All right, it's the same thing. We're finding the component form, magnitude, and angle when we're given 2 points. Same deal, same vibe. So to find our component form, what are we going to do? Change of x and change of y. More specific. Minus 1, which is going to give us the numbers, more specific. 7 and 4. What quadrant is that? 1. We have to have the component form to be able to run our 2 calculations up here. We have to have the Okay. Did you say South Park?
Huh?
Are you talking about South Park? Is that what I just heard you say?
No.
Oh my gosh. How dare I overhear your conversation that you're having during class? What? So our first step with any of these, no matter if they ask for our component form or not, we have to have it to find our magnitude and angle. So we're going to find our component form so that we can find our magnitude. So our magnitude of AB is when we do our square root of the square of each of those pieces. So we're going to have 7 squared and 4 squared. And this is going to give us what? Square root of 65. And it doesn't simplify. Like, that's the length of it. Again, when we get into story problems, we're going to wind up with gross things there. But that's okay. And they're going to have numbers with decimals and stuff. So then let's find our angle. This is our last one for today. We'll do our angle theta, which we find using the inverse tangent or arctangent of y over x. So my y is 4, my x is 7. What is the arctangent or the inverse tangent of 4/7? 29.704. Is that in quadrant 1? Yes. So wherever we're supposed to wind up, we need to check and make sure our angle puts us there. It just gives us an easy way to double check, as opposed to trying to rote memorize. If it's in this place, it matters. So this there, good to go. Okay. So tomorrow and Friday, we are going to keep playing with vectors. Sorry, we don't get fluff days.